Okay, so we have this interesting question here, and in this video, we'll be looking at the solution of this question. So here we can rewrite the left-hand side. It can now become 12 raised to power x minus 16 raised to power x all raised to power 1 over 2 equals 3 raised to power x minus 4 raised to power x. And we can eliminate the power 1 over 2 here by multiplying it with 2 and also multiplying the power on the right hand side by 2. The power on the right hand side is 1. So we're going to multiply here by 2 and also multiply here by 2. So this cancels out the 2, and then we just have only 12 raised to power x minus 16 raised to power x equal to, here I have 3 raised to power x minus 4 raised to power x all raised to power 2, because 1 times 2 is 2. And then we can now expand this one. So I have 12 raised to power x minus 16 raised to power x equals, this one now becomes 3 raised to power x minus 4 raised to power x times 3 raised to power x minus 4 raised to power x. And then we expand here. So we are using 3 raised to power x to multiply both sides, and then we use minus 4 raised to power x to multiply the right hand side here. So this times this gives me 3 raised to power x all raised to power 2, then plus times minus minus, this times this gives me 3 raised to power x dot 4 raised to power x. So I'm done with that one. I'm now on this 4 raised to power x. So minus times plus gives me minus again. 4 raised to power x times 3 raised to power x gives me 3 raised to power x dot 4 raised to power x. Then minus times minus is plus. Then 4 raised to power x times 4 raised to power x gives me 4 raised to power x all raised to power 2. Then the left hand side can now be, 12 can be written as 3 times 4 all raised to power x. 3 times 4 gives you 12. It's okay. Then minus 16 can be written as 4 times 4 all raised to power x. So we can now multiply the powers in the bracket with the power outside the bracket. Of course, the powers in the bracket are 1 and 1. 3 has the power 1 and 4 has the power 1. Likewise here, 4 has power 1 and 4 has power 1. So x times that power 1 is x. Then write your 3. That's 3 raised to power x dot x times 1 is x. You have 4 raised to power x. Minus the same thing here. You have 4 raised to power x dot 4 raised to power x equals, here they are like terms. It's like having minus x to give you minus 2x. So minus 3 raised to power x dot 4 raised to power x minus 3 raised to power x dot 4 raised to power x gives you minus 2 bracket 3 raised to power x dot 4 raised to power x. And of course, I still have my 3 raised to power x all raised to power 2. And then I have my here plus 4 raised to power x all raised to power 2. And then notice that I have 3 raised to power x and 4 raised to power x running through the equation. So it will be easy for me if I now replace them with a particular or with variables. So I can say let 3 raised to power x be m and 4 raised to power x be n, to make my work easy. Then I have to rewrite this one before I do that. This one can now be 4 raised to power x all raised to power 2, and then I still have my 3 raised to power x dot 4 raised to power x, and I have my minus there. Then equals, of course I still have these ones here, 3 raised to power x all squared minus 2 brackets 3 raised to power x dot 4 raised to power x plus 4 raised to power x all squared. And then I can now replace them now. So 4 raised to power x will be replaced with n, and 3 raised to power x will be replaced with m. So here I'll be having mn. This will be mn minus n squared equals to, this one is m squared minus 2 brackets mn close bracket plus this one now n squared. Then I'm moving every value to the left so that 0 will be on the right hand side. So I now have mn minus n squared. This values, m squared becomes minus m squared. This one becomes plus 2mn. And this one becomes minus n squared, and I have equals 0. And then minus n squared minus n squared gives me minus 2n squared. Then plus 2mn and mn gives me plus 3mn. And of course, I have my minus m squared left equal to 0. And then I can multiply through by minus 1 to eliminate the negative sign here. So minus times minus gives me plus. This one gives me minus 3mn. And this one gives me plus m squared, then equal to 0. Then looking at this, I can now happily solve this by factorization method, because this is definitely a quadratic equation. So solving by factorization method, I will then have I'm replacing minus 3mn. By factorization method, I'll have 2n squared. This one becomes minus 2mn minus mn, then plus m squared equals 0. Then picking the first two and finding the HCF, factorizing here, I have 2n is common, 2 cancels 2, n cancels one of the n, I have n left, minus n cancels n, 2 cancels 2, I have m. Then close bracket minus what is common, m is common, open bracket, m cancels m, I have n, plus divided by minus is minus, m squared divided by m is m, then equal to 0. Then refactoring, I have 2n minus m times, these two are common, pick one of them, n minus m equal to 0. Then if this times this is equal to 0, it means either this one is equal to 0 or the n minus m is equal to 0. So solving this, I have 2n equals to m. So dividing through by n, I have 2 equals to m over n. So 2 equals m over n. But remember that my m, right from the beginning, I said that my m is 3 raised by x and n is 4 raised by x. So I'll fix them back. So I'll end up having 2 equals to 3 raised by x over 4 raised by x. And then I will have 2 equals to 3 over 4, everything raised to power x, since the power is common to both of them. Then reversing this to a logarithmic equation, I will have log 3 over 4, log base 3 over 4 equals to x, and I have 2 as the number, the argument here. That is for case 1. Then case 2 is when n minus m equals to 0. So I can have x equals log 2 to the base 3 over 4. Then the second equation here is n minus m equals to 0. I can say n equals to m. Remember the n is 4 raised by x. Or I can divide through by m. Divide here by m and divide here by m. This cancels this. I have 1 left. So I have n over m equals to 1. But n is 4 raised by x over, and the m is 3 raised by x, then equals to this one here, 4 raised by x over 3 raised by x. I can now have 4 over 3 all raised by x, since the x is common, equals to 1. And I can have 4 over 3 raised by x equals 4 over 3 raised by 0, since any value raised by 0 is 1. I can now cancel out the bases. I now have x equals 0 also. So we have x equals 0 and we have x equals log to the base 2, log to the base 3 over 4 of 2. So that's it.